covered in unit time. It is expressed as distance over time. Take a look at this animation carefully. Here is a busy ant moving along a straight line. Observe his motion. Can you describe this motion? The ant covers 3 centimeters every minute. It covers equal distances in equal intervals of time. Here is another example of motion. The car is moving on an expressway. Observe the signboard. Now, look at the speedometer of the car. How can you describe this motion? Yes, the car maintains the same speed. If speed is the same, we know that speed is the distance traveled per unit time. Hence, we can say that the car traveled equal distance and equal intervals of time. Such a type of motion is known as uniform motion. When an object covers equal distance in equal interval of time, then the object is said to be moving with uniform motion. Well, that is not usually the case in real life. The speed of motion usually varies, and hence the distance traveled in equal intervals of time is not the same. Observe this car on a busy street. Notice that the speedometer reading shows unequal readings at equal intervals of time. When an object covers unequal distances in equal intervals of time, then the object is said to be moving with non-uniform motion. Speedometers provided in the automobiles measure the speed of the vehicle that particular instant. This is known as instantaneous speed. Instantaneous speed is defined as speed at a particular instant of time. If the speed varies constantly, how do you describe your rate of motion as a whole? We describe the rate of motion of objects with non-uniform motion by finding the total distance traveled by the object over a span of time. This is referred to as average speed. Average speed is equal to total distance traveled divided by total time taken. It is time for some math now. Let us determine the average speed at which Peter drives. Wind is blowing at a speed of 60 kilometers per hour. Is this information sufficient for smooth sailing of the ship? What do you think is the missing information? Only the numerical value of speed is known. Unless the direction of the wind is known, the sailor is not getting complete information to sail safely. The rate of motion of an object can be more comprehensive if we specify its direction of motion along with its speed. The quantity that specifies both these aspects is called velocity. Recall, Jack lost in the woods. Displacement gives the direction as well. Velocity can also be given by displacement of the body per unit time. That is, velocity v is equal to displacement divided by time. Speed and velocity have the same units, that is, meters per second. Note that people sometimes use the term speed instead of velocity, which is not accurate in physics. Recall how you said a motion is uniform or non-uniform motion in terms of the distance traveled, or the speed with respect to time. And now you know that velocity is speed with direction. How can you say if the velocity of an object is uniform or variable? Yes, since velocity is specified with direction of motion along with its speed, we can say that velocity is variable if either the speed changes or the direction changes. In the case of non-uniform motion, recall that the average speed is given as the total distance traveled by the total time taken. Consider the direction is not changing, that is, the motion is along a straight line. Then, the average velocity is nothing but displacement by time. But is the average speed equal to average velocity always? Let us find out. Jack swims in a 60-meter long pool. He swims from one end to the other and back along the same straight path in 2 minutes. Find the average speed and average velocity of the swimmer. Since Jack swims from one end of the swimming pool to the other and back to the starting point, the distance he covered is 60 meters plus 60 meters, which is 120 meters. Time taken for Jack to swim the entire distance is 2 minutes, or 2 times 60, which is 120 seconds. Average speed is equal to total distance covered by total time taken, that is 120 meters by 120 seconds, or 1 meter per second. Now, velocity is displacement by time. As you know, since Jack has returned back to the starting point, displacement is 0. Hence, average velocity is 0. Are you now ready to compare and contrast speed and velocity? Speed is the distance traveled by an object in a given interval of time. It does not specify direction. Velocity is the displacement of an object in a given interval of time. It includes the direction component. Speed is given by the relation speed is equal to distance traveled divided by time taken, while velocity is equal to displacement divided by time interval with the direction mentioned. Speed can be 0 or positive, but never negative, because distance cannot be negative. The velocity of an object can be negative, positive, or equal to 0, as displacement can take any of these 3 values. Let us do some more math. The cheetah, running at a peak velocity of 100 kilometers per hour, spots its prey at a distance of 100 meters. What is the minimum time it will take to get its prey?